particle moves in a straight line so that t seconds after passing through a fixed point O, its velocity is given by v equals to t squared minus 30t plus 72. Then we're supposed to find the distance between the particle's two positions of instantaneous rest. Our velocity is equal to 0, so that we can be able to work out the value of t when velocity is 0. So solving the quadratic, we are going to get t is equals to, t is going to be equals to 4, or t is equals to 6. We're going to integrate from 4 all the way to 6 this velocity equation, which is 3t squared minus 30t plus 72, and we are integrating with the t. Now what I want to see here, the color of so good. I need to go and try to do some correction to see our rating. I don't know which setting they selected. Let me try to see. Variable here. When you're integrating this variable here, what you're going to do is that you are going to increase the power by 1. It becomes 3, then you divide it by 3. So 3 and that will cancel out. We end up having 3 cubed minus this will become power 2 divided by 2 here becomes 15t, then plus 72t. And then now we are going to integrate that from which region to which region. We are going to integrate that from basically from 4 all the way to 6. Now if you are going to substitute this into your calculator where you have 6t, you are going to substitute this, and then this is going to be equals to 6 cubed minus 15 into 6, yeah, plus 72 into 6. Yeah, so that we shall subtract what? We are going to subtract now 4, so it will be 4 cubed minus 15 into 4 plus 72 into 4. And then if you work out this, you are going to get your answer as 108 minus 112. 108 minus 112. So subtracting, you are going to get your answer as negative 4 meters. But now we are going to take the absolute value because we are talking of distance. So this is going to be 4 meters. Basically, that's what you're supposed to do when you are given a question like this, which involve or which you are supposed to work out. You are supposed to work out. You are supposed to work out questions like this. You're supposed to work out distance, and basically this is questions to do with kinematics. We need to move further. Now when you differentiate this, you're going to say dv dt, that's going to give us our acceleration. So if we differentiate the velocity equation, you're going to get acceleration. So meaning that our dv dt is going to be 6t minus 30. But if you differentiate this, you're going to get plus 0 here. Therefore our acceleration equation becomes 6t minus 30. So remember, we are finding acceleration at which point? At the point here whereby at this point here t is actually equals to 2. So meaning that we are going to say that acceleration at t is equal to 2 is going to be 6 into 2 minus 30, and that's going to be 6, this is 12 minus 30, and the answer is going to be negative 18 meters. Negative 18 meters per second squared. So acceleration is negative, so meaning the object was decelerating. That's why we have a negative value at that point. Okay, now moving to this question. Okay, now moving to this question here, let me just move so that you can be able to see exactly the question I'm talking about. We are told the diagram shows a rectangle ABCD with BC equals to X, and the area of the rectangle is 400 centimeters square. So the area of the rectangle that we are having at this point here is 400 centimeters square. But you can see from the diagram here, BC is basically the width of this shape. So, and the width BC is equivalent to X, is equivalent to X. So what is that information really helping us? We know that area area of a rectangle is length times width. Now, meaning that if we know that the area is 400 and we are looking for the length, we can just substitute our x here, and therefore we can agree together that the length L is basically equal to 400 over x. That's the length. Now, since the shape we are talking about uh, is like this, the shape was given like this, so meaning that this part was removed, this part was removed, and also this part was removed. So we have some sections that were removed like that. But if this is x over 2 radius and this is x over 2 radius, then since the entire length here was equivalent to x, then it means that this section that we are having at this point is also x over 2. So this is x over 2. So meaning we can be able to remove this. We can be able to remove here. Then if this is x over 2, also this part is x over 2. But we have said that the length of this shape, remember we want to find the perimeter of the shaded part. So if we want to find the distance from here to here, but the length is 400 over x, then it means we are going to say 400 over x minus x over 2 equal the x over 2 here, and also there's x over 2 here, so it will be 400 over x minus x over 2. So that will becomes this length here and also this length at this point. So for us to find the perimeter, we need to find, of course we have this part, we need now to find this distance here and also find this distance here. Then we add this distance, this and this for us to find the perimeter. So which will mean that in the process of working out our question here, remember circumference of a circle is 2 pi r. That is the circumference of a circle. Circumference of a circle is given by 2 pi r. That is circumference of a circle. But if we are talking of a quarter a circle, then we are going to say now this distance that we are talking about here is a quarter of a circle. Then we're going to say this distance, let me call it c. This distance c is going to be divided by 4. Now our distance c, this distance c is going to be circumference of a circle over 4. But remember there are two of them, so we are going to multiply by 2. Once we get this one, we times 2 so that we take care of this one and this one here, and then add distance around to find the perimeter. So we are going to say therefore that c This distance c, that's the one that I'm referring to, is 2 times pi over 4 times the radius. The radius is x over 2. This and this will cancel out, and then we're going to have 1 over 4 pi x. But remember, there are two of them, so we are going to take note of that. We're going to say perimeter is going to be equals to 1 over 4 pi x times 2, right? Times 2, then plus 2 times, yeah, right? We are going to say plus 2 times. I'm going to have these two of them here. This is 400 over x minus x over 2. Why times 2? Because of this also. Then I'm going to say plus this and this. So this is going x over 2 plus x over 2 is going to give us just x. Yeah, is going to give us x at this point. I think I need to adjust the camera a little bit so that we can be able to see some of these parts, some of the parts here. So we are going to say now plus x. And the reason as to why I'm saying plus x is because x over 2 plus x over 2 will give us x. 400 over x minus x over 2 times 2, because there's this part and there's this part. And then I also got this arc length here is 2 pi r, and then I multiplied by 2 here because there's this section and there's this section. So if we simplify this perimeter expression, our perimeter expression is going to reduce to what? Our perimeter expression, if you simplify it, it's going to end up to be 800 over x, 800 over x minus plus pi x over 2, pi. Simplifying the perimeter expression, we are going to get our answer as 800 over x plus pi x over 2. So this is the expression for the perimeter. Then remember, we are told that we are supposed to work out, given that x can vary, find the value of x that gives minimum value of the perimeter. We know at minimum dp dx will be equals to 0 for minimum value. If you differentiate this, you are going to get, so meaning that differentiating this, we're going to have dp dx is going to be, differentiating this, we're going to get pi over 2. Differentiating this expression is just like having 800 x negative 1. Differentiating this, we're going to take the power down, negative 1 becomes negative 800 x negative 2, because you are going to subtract 1 here, so that you're having that, and basically that becomes minus 800 over x squared, because if you are having this, you can write it as 800 over x positive 2 now. That is what our expression is going to reduce to. So because we want to solve for x at minimum point, we have said at minimum point dp dx is going to be equals to 0. That means that we are going to take this equal to 0, so we shall have pi over 2 minus 800 over x squared is equal to 0, which will mean that this is going to be pi over 2 is equals to 800 over x squared times x squared both sides. We end up having x squared is equals to 800 times 2 over pi. Then find square root. Our x, in this case, our x, if you find the square root of that, you are going to get our x equals to 22.57 centimeters. 22.57 7 centimeters. Now, this is the value of x, but remember the question expected us, hence find the value of that perimeter. Find the value of that perimeter. And perimeter now at x is this value is going to be equals to, expression for perimeter is this, it's going to be equals to 800 over x, but x is 22.57 plus pi times 22.57 over 2. And if you work out, your answer is going to be close to 70.9 centimeters. 70.9 centimeters, because we were told in this question all the measurements, all the lengths are given in centimeters. So basically check your answer in this. And when, according to additional math, when you do questions like this one, sir, whereby you have decimals, ensure you give your answers correct to 4 decimal places or 3 significant figures. So like this one is 3 SF, 3 significant figures. If you have gotten value from this video, consider subscribing so that anytime I'm going to upload a tutorial, you'll be notified. Now, working out the area under the graph will give you the distance covered by the object. Working out the gradient of this will give you the acceleration of the object. And there is nothing much apart from whatever we have mentioned here. You're going to be asking this particular kind of questions. So let's see, what is the next question? The next question for this part here, the next question, they are saying that find the distance traveled by the particle p. Find the distance traveled by the particle p. So finding the distance traveled by this particle, finding the distance traveled by the particle, finding the distance traveled by the particle. Now I'm going to consider this as area A. So I'm going to work out the area of this shape, and then I'm going to find the area B, and then I'll find also area C. Then I'll finally add area D. I plug in, if I plug in 30 times 25 is going to give me 750. So I'm going to say this 750. Then I'm going to consider shape B. B is what? B is a triangle. But what is the distance surely from B, the base of this triangle? The base is going to be, because this mark, if you can look at this mark here, yeah, this mark here, this mark is basically this. What mark is this? This is 35. So what is 25 and 35? That is 10. So meaning the base is 10. And what is the height of this triangle? It's moving from 15 all the way to 30. So that is actually 15. The height of this triangle is 15. So B is going to be a half base, which is 10 times height, which is 15. And that is going to translate to, if you work it out, you are going to get 75 at that point. The next area we shall focus also is C. C here. Let's look at what is the base, because C is from 25 and this end for C is actually 50. So this 50, right? Yeah, already it's there. It's 50. So 50 minus 25. So the area of C is going to be length times width, 25, because you have to find the difference, 25 times the height. The height is 15. So if you work it out, that is 25 times 15, which translates 375. And then we are almost done. We have D. D is which shape? D is a triangle. the base of that triangle we can see is 50 to 60, so it's 10, and the height is 15. So area times 10 times 15, this 5, and this is actually going to be 75. So total area is going to be 750 plus 75 plus 375 plus 75. If we put that in our calculator, let's see, 750 plus 75 plus 375 plus 75, we get 1275. So the answer here is 1275 meters. So don't make a mistake and say area meter square, because area under the graph represents distance moved by the object. So the units for this area should be what? Meters, because area represents distance. So basically that's what the question was. Let us now move to the next section and see what were we expected to do in that area. What are we expected to do in this next section? Look at what we are doing. In order to find that gradient, remember from this point to this point here is 25, and this is actually 35, and then the run here is 10. And let's check what is the rise of this. The rise is moving all the way to point here. So we are just finding the gradient of this line here. For you to find the acceleration, you are finding the gradient of that, but we must know what is the change in velocity here. It's moving from 15 all the way to 30, so that is actually 15. So therefore we can be able to say deceleration is equals to 15 over 10, which is 1.5 meter per second square. Now, because it's a deceleration, you don't have to put the negative again. But if they ask you find the acceleration in that region, it means you will indicate negative, which implies that the object is decelerating. But since they talked about deceleration, you don't have to put a negative sign for this particular part. Velocity time graph, and we have different sections. If you can look at this velocity time graph that we are given here, for instance, at this point here we have constant velocity. This section, constant velocity, and the velocity in that case is basically 6 meter per second. So velocity here is constant and is 6 meter per second. But in this section down here, velocity is constant, but now it's what? It's 3 meters per second, because it's quite indicated at this point here. It's quite indicated at this point. So here, this section here is going to have 6 meter per second as a constant velocity. Then we have this section down here, which is having velocity of 3 meters per second, which is constant. Now, something that is very important for you to understand when it comes to this question, when you're going to draw a velocity displacement time graph, you need to understand that the gradient of that displacement time graph is going to represent the velocity. So if you are going to draw a displacement time graph for this section, the gradient of displacement time graph must have a gradient of 6. But the gradient for this part will have a gradient of 3. But the time interval is for this first section from 0 to 10. Now let us go straight. So we are saying that from 0 to 10, gradient velocity is 6 meters per second. So gradient of your line is going to be 6. From 10 to where? All the way to what? 10 or 10 is 10 here, all 10 all the way to 20. We are going to have all the way to 20. Velocity is constant, which is 3 meter per second, and then it means the gradient in your graph is going to be 3. So let us now go ahead and try to draw that graph so that we can be able to earn our marks. So we are going to position our ruler properly from the origin, and then you identify 10. When you move up, you check where you're going to meet 60 is where 60. Yeah. So our graph will be like that. So let me from this, the graph will go straight. So our graph will end up here. So this is the first section of the graph. And the reason as to why we are saying that is the first section of the graph is because that if we work out the gradient of this line, because this is a displacement time graph, it must give us a gradient of 6. Yeah, because you can see on this section here you'll have 60, and down here you'll have 10. So if you work out rise over run 60 over 10, you are going to get a gradient of 6. Now that gradient of 6 that we have is going now to be the first section. Remember, the second section of the graph was from 10 all the way to 20, from 10 all the way to 20. But now, since we are talking of a gradient of 3, it means our gradient should be 3. But what is the difference between 10 and 20? The difference here is the run, because gradient is rise over run. So the run will be 10, because from 10 all the way to 20, the difference is 10. But what should be this value here first so that we can have a gradient of 3? This value must be what? This value must be 30. Yeah? This value must be 30. 30 over 10 will give us 3. But already at this point here, this point here, then it means that we must move 30 up, so that that will end up where? 60 plus 30, that will give us 90. So my graph will be like that. I have to adjust it until it's at point where it's 90. It is 90 will be somewhere here. Up here. Of course, you look at 90 on this other side, so 90 will be somewhere. So I line like that. And that is how that graph is going to. That's how the first section, and this is the last section of this graph. The reason you are supposed to give at that point is that, remember, the graph of exponent is actually, it looks like this, all right? And especially for this one, our graph is going to, our horizontal asymptote is going to be at 6, at 6. So the graph is never going, is always going to be like that. That is how this graph is going to look like. Now, something that you were to mention here is that E is to T is always, E is to T is always positive. Is always positive. So there's no point this will ever be 0, because this is 6 and this value is always positive. Then this particle will never rest at any given point. So this is the reason you want to give that. Find the value of t, which the acceleration of r is 12 meter per second square. We are supposed to find acceleration. If you differentiate dv dt is going to be what? if you are differentiating this, you are going to differentiate the top and bring the power down. So that's going to be 8e is to 2t. Then if you differentiate this, we are going to say plus 0. So which means that our acceleration equation is going to be 8e is to 2t. And then we are told we are solving where acceleration is 12. So we are going to say 8e is to 2t is equals to 12 divided by 8 divided by 8. E is to 2t is equals to what? This is going to be this going to 4 is going to be 3 over 2, right? Going to be 3 over 2. Now we are supposed to give exact value, so meaning that we are going to introduce ln both sides, and that's going to be e is to 2t is equals to ln of 3 over 2, which means that we can take now 2t ln of e is equals to ln of 3 over 2. 2t is equals to ln of 3 over 2. Our t is going to be 1 over 2 ln of 3 over 2. So basically, we can also say our t is ln of square root of 3 over 2 as our final answer in that case. So whenever you are given an equation which is a velocity time equation, for you to work out the distance in the interval, it means you are supposed to integrate this within the limit that is provided. So in this question here, it means that we are supposed to do the integration. We are supposed to integrate. We are supposed to integrate this equation for is to 2t plus 6 with respect to t from 0.4 all the way to 0.5. So basically that's what we're going to do in this question. And when you are doing integration, integrating an exponent, you differentiate the top, you divide it. So we are going to say this is going to be 4. To integrate this, we are going to say this is going to be 4 e is to 2t over differentiate the top, it gives you 2, then plus integrating 6, you are going to get 60. Then the limit of integration is 0.4 all the way to 0.5. This 2 is going to simplify, and then we have 2 e is to 2t plus 60, and the limit of integration 0.4, 0.5, 2 e is to 2 into 0.5 plus 6 into 0.5 minus, substituting now 4 is going to be 2 into 2, 0.4 plus 6 into 0.4. So if you work it out using your calculator and try to figure it out what's going to give you, you shall have here 8.44 minus 6.85, and that answer is going to be 1.59 meters as the displacement of this particular question. So if you have gotten value from this video, consider subscribing so that anytime we're going to upload further tutorials, you'll be notified. See you in the next video.